So our fourth problem that we have here, and again the directions are just to simplify. I have the square root of the cube root of 27 a to the 9th. Oops, that's pretty gross. Let's do this. A to the 9th, b to the 12th, c to the 3rd, d to the 21st. Okay? And so what I need to do, and everybody starts freaking out about this, what I need to do is I need to simplify the cube root of all of that. And whatever my answer is, that all goes inside the square root. The one thing to remember is, in order to do this, these are all going to have to turn out perfectly in order to then put them into the square root. Okay, so everything's going to work out nicely. So for 27, I can break that up into 9 and 3, and then 3 and 3. So that's a group of 3, and so I'm going to put that 3 in there. For my A, I'm going to do 9 divided by 3, and I get 3. For my B, I'm going to do 12 divided by 3, and I'm going to get 4. For my C, I'm going to do 3 divided by 3, and I'm going to get a 1. And for my D, I'm going to do 21 divided by 3, and I get a 7. So again, all of those, they're going to be perfect. It's all going to work out perfectly, okay? Now for this next step, it's not all going to be perfect, okay? So for some of you, you might want to break that up if that's what you've been doing. So square root of b to the 4th, square root of c to the 1st, square root of d to the 7th, okay? So for the 3, there's nothing that I can break up, so that's square root of 3. For a to the 3rd, 3 divided by 2 is 1 with a remainder of 1. So that means I'm going to have a square root of a. For b, I'm going to do 4 divided by 2, and that is 2 with a remainder of 0. So I'm going to have b squared. For the c, 1 divided by 2, that's going to be 0 with a remainder of 1. So that means I'm still going to have the square root of c. And for d to the 7th, I'm going to do 7 divided by 2. I get 3 with a remainder of 1. So that means I'm going to have d to the 3rd square root of d. And so then for the final answer, I'm just going to join all of those together. And I'm go ahead and do that on the next page because I don't have enough room here. So I'm going to take everything that's outside. So that's the a, the b squared, and the d to the 3rd. So I'm going to write that here, a, b squared, d to the 3rd, and then I'm going to have the square root of everything that's inside. So 3a, c, and d. Okay, so I'm going to have 3a, c, and d. And then my answer is all complete. So that's nothing to freak out about. So don't worry about it. Relax. It all works out just nicely. Let's look at our fifth one here. I have 3n minus 4 square root of 5n squared all over 5 times 25n cubed. Okay? So what I'm actually going to do is, and I know I told you in the last lesson and even in the lesson before it, to multiply or divide and try to get everything done before you simplify. However, anytime rationalizing comes into play, I'm going to see if I can simplify anything before I rationalize, just because then it makes life a little bit easier and there's less to actually rationalize. So what I can see here is I've got that n squared. So 2 divided by 2 is 1 with a remainder of 0. So I can actually take out an n to the first and I don't have anything in there. So I've got 3n minus 4n square root of 5 all over, and now I'm going to take care of this. So that 25 I can break out into 5 and 5. So I'm going to take out a 5 and I need to multiply it by that 5, so I'm going to get 25. And then that n cubed, I'm going to do 3 divided by 2. 2 goes into 3 once with a remainder of 1. So I can actually take out an n and I'm just left with a square root of n there. Okay, so that is very, very important just to be aware of and to realize that sometimes you might want to simplify actually before you rationalize. So now I'm going to rationalize and I'm going to multiply by the square root of n over the square root of n. I'm going to distribute that to both parts of that binomial in the numerator. So that means I'm going to have 3n square root of n minus 4n square root of 5n, and that's going to be all over 25 n to the second power, because when I multiply square root of n times square root of n, I get n, and I need to multiply that n by that. So n times n gives you n squared. So now at this time, I'm going to look at my 3n, my 4n, and my 25n squared, and I'm going to ask myself, is there anything that I can divide them all by? And 3, 4, and 25, they don't have anything in common. However, all three of those have an n in common. So I'm going to go ahead and divide all of those by n. So when I do that, 3n divided by n just gives me 3. So I'm going to have the 3 square root of n minus 4n divided by n is just 4. And then I'm going to have the square root of 5n all over the 25. And then n squared divided by n is just going to be n. So at that point, I now have everything as simplified as I most possibly can. Now let's look at number 6. Number 6 is like an ACT problem, so you might want to star this because it's probably going to show up. So if 3 square root of 7 over a square root of 7 equals 3 square root of 7 over 7, so if that is true, what does a equal? And so a lot of people freak out over this, but let's think about this. This is an equation, okay? Notice that my numerators are equal to each other because of that equal sign. 3 square root of 7 equals 3 square root of 7. So what I can actually do is I can set an equation up. I can do a square root of 7 equals 7. So to get a alone, I would have to divide by the square root of 7. So a equals 7 over the square root of 7. And now, due to our mad rationalizing skills, I can rationalize that denominator. So then I get 7 square root of 7 all over 7. And that equals a. Now, one catch. I'm not 100% done because I can actually reduce those 7s. I can divide them each by 7. So it doesn't quite give me my final answer until I reduce the 7 over 7 because both of them are outside of that square root. So then once I do that, I get 1 square root of 7 over 1, which just turns out to be square root of 7. So this here, that is my final answer. So a equals the square root of 7. Okay? And I have one more to look at with you to kind of wrap up this as another ACT problem. So if the fourth root of 3x equals 2.8, then x equals what? Okay? So what I'm actually going to have to do is I'm going to set up my equation. Now, to undo a fourth root, you have to raise it to the fourth power. Just like to undo a square root, you have to square it, something like that. So, when I take the fourth power of the fourth root, I get whatever's inside, that 3x. And then I'm going to do 2.8 raised to the fourth power. You get something like 61.4656, okay? And then in order to find out what x equals, I then have to divide by 3. And this is an ACT question, so sometimes like it's really all just depends on the answer choices, so you'll just want to pay attention to my directions that I give. In this case, we're going to round to the nearest tenth. So when I divide by 3, I get 20.4885. And rounding to the nearest tenth, that's one decimal place. That 8 makes the 4 bump up to a 5, so I get 20.5. And that wraps up rationalizing any denominators.